Tom Brooks. Introduction. The HESI Admission Assessment, HESI A2 exam, is a critical step for students aspiring to enter nursing and allied health programs. This standardized test serves as both a measure of academic readiness and an indicator of potential success in demanding healthcare courses. Preparing effectively for the HESI A2 requires a thorough understanding of the exam structure, the purpose of its scoring system, and strategies to optimize performance. This guide aims to provide comprehensive insights into these aspects to set up for success. Purpose of the test and scoring system. The primary purpose of the HESI A2 is to assess the academic readiness of candidates for rigorous nursing and allied health programs. It identifies strengths and areas for improvement, helping educators design appropriate support for students. The test also acts as a predictive tool, linking performance to potential success in healthcare coursework and clinical practice. Scoring on the HESI A2 is calculated as a percentage for each section. Scores typically range from 0 to 100%, with individual institutions setting their benchmarks for acceptance. Many schools require a minimum score of 75% to 85% in each section, though higher scores improve competitiveness. Composite scores, averages of all sections taken, may also be used to gauge overall readiness. The test does not penalize for incorrect answers, making it advantageous to attempt every question. This scoring method underscores the importance of strategic time management and educated guessing when unsure of an answer. Furthermore, understanding how individual section scores contribute to admission decisions is vital for prioritizing study efforts. Study strategies and test-taking tips. Preparing for the HESI A2 involves a strategic blend of reviewing content, practicing test questions, and cultivating effective test-taking habits. To start, familiarize yourself with the test format and content areas. Use official resources or reputable study guides that align with the latest HESI A2 requirements. Study strategies. Number 1, create a study plan. Divide your preparation time to focus on each test section systematically. Allocate more time to areas where you're less confident while maintaining regular review of stronger areas. Number 2, use practice tests. Practice tests are invaluable for identifying strengths and weaknesses. They mimic the actual exam environment, helping you build confidence and refine your timing. Number 3, master core concepts. Ensure you have a solid grasp of fundamental topics, especially in math and science. For example, practice conversions and dosages in math, and review cellular biology, chemical reactions, and human anatomy in science. Number 4, flashcards and mnemonics. Use these tools to memorize vocabulary, formulas, and other key details. Mnemonics can simplify complex concepts, aiding retention. Number 5, group study. Collaborate learning with peers can provide diverse perspectives and mutual support. Sharing resources and testing each other improves comprehension and recall. Number 6, professional resources. Invest in quality study materials, including books, online courses, and video tutorials. These often provide structured content aligned with the exam's focus areas. Test-taking tips. Number 1, time management. Allocate your time wisely. Spend a few minutes previewing each section to gauge the question types and their difficulty levels. Aim to leave a buffer for reviewing answers. Number 2, Read carefully. Pay attention to instructions and questions. Misinterpreting questions due to haste can lead to avoidable errors. Number 3, eliminate wrong answers. Narrowing down choices improves your chances when guessing. Disregard options that are clearly incorrect to focus on plausible answers. Number 4, stay calm. Anxiety can impair performance. Practice deep breathing techniques to maintain focus and approach each question with a clear mind. Number 5, take breaks. Utilize allowed breaks to relax and recharge. Brief moments of rest can improve concentration for subsequent sections. Number 6, check your work. If time permits, review your answers for mistakes or skipped questions. Double-check calculations in the math section for accuracy. By understanding the HESI A2 structure, purpose, and preparation strategies, you can approach the exam with confidence and competence. This foundation not only increases the likelihood of success, but also builds skills critical for your academic and professional journey in healthcare. Throughout your preparation, remember that consistent effort and a positive mindset are key to overcoming challenges and achieving your goals. Chapter 1, Understanding IT Hardware Fundamentals. Welcome to the Foundation of IT, Hardware. In this chapter, we'll explore the essential components that make up modern computer systems. Whether you're building a PC, troubleshooting hardware issues, or preparing for your CompTIA A+ exam, understanding the basics of hardware is crucial. Let's break it down step by step. Types of computers and components. Computers come in various forms, each designed for specific purposes. Here are the most common types and their components. 1. Desktop computers, designed for home or office use, easily upgradable and customizable with parts like graphic cards, memory, and storage. Number 2. Laptops and notebooks, portable computers with integrated screens, keyboards, and batteries. Compact design limits hardware upgrades compared to desktops. 3. Servers, power machines designed to manage networks, applications, and databases. Equipped with the high-capacity CPUs, memory, and redundant power supplies. Number 4. Mobile devices, smartphones and tablets with compact hardware optimized for portability. Key components across all systems. Input devices, keyboards, mice, touchscreens. Output devices, monitors, printers, speakers. System unit, the central housing for the motherboard, CPU, RAM, and storage. Motherboards, CPUs, and RAM overview. 1. Motherboard, system board, the backbone of the computer that connects all hardware components. Key features: form factor, ATX, micro ATX, mini ITX. Chipsets, determines compatibility with CPUs, RAM, and expansion slots. Slots and ports, PCIe for graphics cards, SATAs for storage, and USB ports for peripherals. Number 2, CPU, Central Processing Unit, the brain of the computer, responsible for executing instructions. Key terms: clock speed, measured in gigahertz, determines processing speed. Cores, more cores, better multitasking. Sockets, ensure CPU compatibility with the motherboard, for instance Intel LGA or AMD AM4. Number 3, RAM, random access memory, temporary memory that stores data and instructions the CPU needs to access quickly. Types of RAM: DDR4, DDR5, Latest generations offer faster speeds. Capacity, measured in GB. More RAM improves multitasking. Real-world example. Imagine troubleshooting a computer that's running slow. By checking the CPU utilization and available RAM, you can pinpoint whether an upgrade to the CPU or adding more RAM is needed. Storage devices, HDD, SSD, NVMe. Storage is where your system keeps all data, operating systems, applications, and files. Here's a breakdown of the most common storage technologies. 1. HDD, hard disk drive, traditional mechanical storage with spinning platters. Pros, high capacity, low cost. Cons, slower speeds, more prone to failure. Number 2, SSD, solid-state drive. No moving parts, uses flash memory to store data. Pros, fast read, write speeds, more durable than HDDs. Cons, higher costs per GB than HDDs. Number 3, NVMe, non-volatile memory express. The fastest storage option, designed for high-speed data access. Connects directly to the motherboard via the PCIe interface. Ideal for gaming, video editing, or other performance-intensive tasks. Choosing the right storage for your needs. Budget systems combine a small SSD for the operating system and an HDD for mass storage. Performance systems use NVMe drives for the fastest boot and load times. Computers come in various forms, but all share common hardware components. The motherboard is the hub that connects the CPU, RAM, and storage devices. Understanding storage options, HDD, SSD, NVMe, is crucial for building or upgrading systems. By mastering these fundamentals, you'll not only ace this portion of the exam, but also build a strong foundation for troubleshooting and configuring hardware. Let's move to the next chapter, where we'll dive into peripherals and their role in IT systems. Chapter 2. Configuring and Troubleshooting Peripherals. In this chapter, we'll explore the world of peripherals, essential devices that expand a computer's functionality. These peripherals allow users to interact with computers, from inputting data to viewing output and managing printed documents. You'll learn how to configure and troubleshoot common peripherals such as input devices like keyboards and mice, output devices, monitors, and devices used for printing and scanning. Input-output devices. Input devices allow users to interact with the computer by entering data, while output devices display or present the processed data. Here's a breakdown of these essential peripherals. 1. Keyboards. Keyboards are the primary input device for entering text and commands into a computer. They come in various designs and layouts, each suited to different tasks. Types of keyboards. Mechanical keyboards, known for their tactile feedback and durability. Ideal for typing intensive tasks or gaming. Membrane keyboards, typically quieter and more affordable, but less durable. Wireless keyboards, connect to the computer via Bluetooth or a USB receiver. Ergonomic keyboards, designed for comfort, reducing strain on wrists during long typing sessions. Common issues in troubleshooting. Unresponsive keys. Ensure the keyboard is properly connected. Try restarting the system or test the keyboard on another computer. Sticky keys. Check for dirt or debris under the keys. If needed, clean the keyboard using compressed air or gentle wipes. Wireless keyboards not connecting. Replace the batteries or check the connection settings in the device manager. Number 2, mice. Mouse devices. Mice are essential input devices that allow users to control the pointer on the screen. They come in various forms, including wired, wireless, and touch-based mice. Types of mice. Optical mouse uses infrared light to detect movement, works on most surfaces. Laser mouse, more precise than optical mice, often used for gaming or graphic design. Wireless mouse connects via Bluetooth or a USB receiver, offering greater mobility. Trackball mouse. The ball on top allows users to move the cursor without moving the mouse itself. Useful for tight spaces or accessibility needs. Common issues and troubleshooting. Unresponsive or jumping cursor. Try changing the surface. Use a mouse pad if needed, or check the mouse settings in the control panel. Wireless mouse not connecting. Replace the batteries. Check the USB receiver, or try repairing the device. Buttons not responding. Check the driver software, or test the mouse on another computer to rule out hardware failure. Number 3, monitors, display devices. Monitors are output devices that allow users to see the visual output from the computer. Choosing the right monitor is essential for comfort and productivity. Types of monitors. LED monitors, commonly used for general tasks. Energy efficient and widely available. LCD monitors, known for vibrant colors and wide viewing angles. Curved monitors provide a more immersive experience, reducing distortion at the edges of the screen. Touchscreen monitors allow direct interaction with the screen through touch, ideal for kiosks or interactive devices. Common issues in troubleshooting. No display on screen. Check if the monitor is powered on. Ensure the cables are securely connected, and confirm that the correct input source is selected. Flickering or dim display. Adjust the refresh rate or resolution in the display settings. Check for loose cables or faulty connections. Dead pixels or lines. A hardware issue. Testing with another monitor or contacting the manufacturer may be necessary. Printers and scanners. Setup and maintenance. Printers and scanners are essential for producing physical copies of digital documents. Proper setup and regular maintenance ensure optimal performance and longevity. Number 1, printers. Printers are output devices that allow you to produce hard copies of documents and images. The most common types of printers are inkjet, laser, and thermal printers. Types of printers. Inkjet printers use liquid ink to produce high-quality prints, especially for photos. Laser printers use toner to produce high-speed, high-quality prints, especially for text-heavy documents. Thermal printers used in point-of-sale POS systems for printing receipts and labels. Setting up a printer. Wired printers connect to the computer using a USB cable. Ensure the printer drivers are installed for your operating system. Wireless printers connect to the same network as your computer or mobile device. Use the printer's setup wizard or mobile app for easy installation. Network printers, often used in office environments. These printers connect to a local network and can be accessed by multiple users. Make sure the printer's IP address is correctly configured on all connected devices. Common printer issues and troubleshooting. Paper jams. Open the printer and remove any stuck paper. Always check the paper tray and make sure it's correctly aligned. Printer not responding. Ensure the printer is powered on. Check the network connection or restart both the printer and the computer. Low ink toner. Check ink or toner levels through the printer's software and replace cartridges as necessary. Number 2, scanners. Scanners convert physical documents into digital files. They are useful for creating electronic copies of text, images, or receipts. Types of scanners. Flatbed scanners. Documents are placed on a glass surface for scanning, ideal for photos, books, or large documents. Sheet-fed scanners. Documents are automatically pulled through the scanner for fast scanning, ideal for bulk scanning. Portable scanners. Compact and lightweight, often used for scanning on the go. Setting up a scanner. Install scanner drivers from the manufacturer's website or use built-in drivers on most operating systems. Use the scanning software to set preferences, resolution, color format before scanning documents. Wireless scanners connect via Wi-Fi or Bluetooth, ensuring proper network setup. Common scanner issues and troubleshooting. Scan quality issues. Adjust the resolution or settings in the scanning software. Clean the scanner glass to avoid smudges on the final image. Scanner not recognized. Check for updated drivers. Reconnect the USB or wireless connection and verify the scanner is powered on. Paper jams in feeders. Remove any stuck paper and check the paper path for obstructions. Input devices like keyboards and mice enable user interaction, while output devices like monitors and printers deliver results. Troubleshooting peripherals often involves checking connections, updating drivers, and ensuring compatibility with the system. Regular maintenance, such as cleaning printers and scanners, ensures smooth operation and extends the life of the device. By mastering peripheral configuration and troubleshooting, you'll be well equipped to handle common IT tasks, making you a valuable asset to any team. In the next chapter, we'll dive into networking fundamentals and connectivity, which will help you understand how devices communicate with each other. Chapter 3. Networking Basics. Networking is the backbone of modern IT infrastructure, enabling computers and devices to communicate, share resources, and access information across the world. In this chapter, we will break down the essential concepts of networking, covering different network types, key devices such as routers and switches, and understanding IP addressing. You'll also learn how to troubleshoot common network issues. Network types and connections. There are different types of networks, each designed to meet specific needs. Understanding these will help you determine the best configuration for a particular environment, whether at home, in a small office, or in a large enterprise setting. Number 1. Local Area Network, LAN. Definition: a network that covers a small geographical area, typically a single building or a campus. Purpose: LANs are used to connect computers, printers, and other devices within a limited space, allowing them to share resources like files and printers. Components: LANs typically consists of computers, networking devices such as switches or routers, and cables, Ethernet or fiber optics. Number 2. Wide Area Network, WAN. Definition: a network that spans a large geographical area, such as a city, country, or even across continents. Purpose: WAN or WANs are used to connect LANs and other networks, allowing communication over long distances. Example: the Internet itself is the largest example of a WAN, connecting billions of devices globally. Number 3. Metropolitan Area Network, MAN. Definition: a network that covers a city or large campus, typically connecting multiple LANs within a specific region. Purpose: MANs are often used by organizations with multiple locations in a city or large campus. Number 4, personal area network, PAN. Definition: a small network for personal devices like smartphones, laptops, and wearables. Purpose: PANs are typically used for wireless communication, such as Bluetooth between devices. Routers, switches, and access points explained. Understanding the key networking devices that help manage data flow and connectivity in networks is essential for both setting up and troubleshooting networks. 1. Routers. Function: routers are devices that forward data packets between networks. They connect LANs and WANs, like the Internet, and manage data traffic. How they work: routers examine the destination IP address of incoming data packets and determine the best route for them to reach to their destination. Example: a home router connects your local network, LAN, to your Internet Service Provider, ISP, allowing all devices in the house to share one Internet connection. Key features: NAT, Network Address Translation, translates private IP addresses on your LAN to a public IP address for the Internet access. DHCP, Dynamic Host Configuration Protocol, assigns IP addresses automatically to devices on the network. Firewall, provides security by filtering incoming and outgoing traffic. Number 2, switches. Function: switches are used to connect devices within a LAN, such as computers, printers, and servers. They operate at the data link layer, layer 2 of the OSI model. How they work: switches receive data packets and forward them to the correct device based on its MAC address. Example: in an office network, a switch connects multiple computers, allowing them to communicate with one another and access shared resources. Key features: port density. Switches come with multiple ports to connect several devices simultaneously. Layer 3 switches. These switches also support routing functions and can direct traffic between different subnets in larger networks. Number 3, access points, APs. Function: access points provide wireless connectivity to devices like laptops, smartphones, and tablets within a network. They allow Wi-Fi-enabled devices to connect to the wired LAN. How they work: APs bridge the gap between the wireless devices and the wired network, enabling wireless communication. Example: a Wi-Fi router is essentially an access point that provides wireless access to the Internet for all devices within its range. Key features: SSID, Service Set Identifier, the name of the Wi-Fi network broadcasted by the AP. Security protocols: APs use encryption, like WPA2 or WPA3, to secure wireless communication and prevent unauthorized access. Basic IP addressing and troubleshooting. Every device on a network needs a unique identifier to send and receive data. This is where IP addresses come in. Understanding how IP addressing works is crucial for troubleshooting network issues. Number 1, what is an IP address? An IP address, Internet Protocol Address, is a unique string of numbers separated by periods, IPv4, or colons, IPv6. It serves as the address that devices use to identify and communicate with each other over a network. IPv4, written in 4 groups of numbers, for instance, 192.168.1.1, each ranging from 0 to 255. IPv6, a newer format, written in 8 groups of hexadecimal numbers designed to address the limitations of IPv4. Number 2, subnets and subnetting. Subnet, a division of a larger network created by dividing an IP address range into smaller segments. Subnetting allows more efficient use of IP addresses and helps organize networks into logical sections. Example, in a home network, you might have a subnet for devices like computers and another for guest devices. Number 3, DHCP versus static IP addressing. DHCP, which is Dynamic Host Configuration Protocol. This is the most common method of assigning IP addresses on a network. A router or server automatically assigns an IP address to each device when it connects to the network. Static IP addressing. In this method, an IP address is manually assigned to a device, ensuring it always has the same address every time it connects to the network. Number 4, common IP address issues and troubleshooting. IP conflict occurs when 2 devices are assigned the same IP address. Solution: release and renew the IP address using the IP configure command, Windows, or check the router's DHCP settings. No internet access. If a device is connected to the network but cannot access the internet, check the IP configuration and verify the router is connected to the ISP. Ping tests. Use the ping command to test the connection between your computer and the other devices or websites. A successful ping indicates that the network connection is working, while a timeout suggests a network issue. Incorrect subnet mask. Incorrect subnet mask. An incorrect subnet mask can prevent devices from communicating properly within a network. Ensure that all devices on the same subnet have matching subnet masks. Network types: LAN, WAN, MAN, and PAN serve different purposes depending on the size and scope of the network. Routers, switches, and access points. Routers connect networks. Switches manage traffic within a LAN, and access points provide wireless connectivity. IP addressing. Every device needs a unique IP address for network communication, and proper configuration is essential for smooth network operation. Troubleshooting. Common network issues such as IP conflicts, no internet access, and incorrect subnetting can be resolved using diagnostic tools like ping and checking IP configurations. Chapter 4. Mobile Devices Essentials. Mobile devices have become an integral part of everyday life, from laptops that allow for productivity on the go to smartphones and tablets that keep us connected and entertained. As a CompTIA A+ technician, understanding the hardware of these devices and knowing how to troubleshoot common issues is essential. In this chapter, we will cover the key hardware components of laptops, tablets, and smartphones, as well as guide you through troubleshooting common mobile device issues. Laptops, tablets, and smartphones hardware. Mobile devices, though smaller than desktop computers, contain many of the same components, but are designed for portability and efficient power usage. Let's take a closer look at the key hardware in laptops, tablets, and smartphones. Number 1. Laptops. Hardware overview. Laptops are portable computers that offer similar functionality to desktops, but in a compact, all-in-one design. Laptops are designed for mobility, meaning that their internal components need to be more energy efficient, smaller, and lighter than those in traditional desktop computers. Key components: CPU processor, the brain of the laptop, responsible for executing instructions. Laptop CPUs are usually lower power, such as Intel's mobile processors, Core i3, i5, i7, or AMD's Ryzen series. Memory for RAM. Like desktop computers, laptops use RAM to store temporary data. However, laptop RAM is often soldered to the motherboard, making upgrades more difficult. Storage, SSD, HDD. Laptops typically use SSD solid-state drives for faster read-write speeds, but some older models may still use HDDs, hard disk drives. Motherboard, the main circuit board that houses the CPU, RAM, storage connections, and other key components. Display. Laptops feature built-in LCD or LED screens, often ranging from 11 to 17 inches in size. High-end models may use IPS or OLED panels for better color and clarity. Battery. Laptops rely on rechargeable batteries for power. Battery life can vary depending on the laptop's power consumption and capacity. Ports. Common ports include USB-A, USB-C, HDMI, Ethernet for wired network connections, and audio jacks. Newer laptops increasingly rely on USB-C ports for multiple functions, charging, data transfer, video output. Other features: keyboard and trackpad. Most laptops come with built-in keyboards and trackpads for navigation and input. Some models may offer a touchscreen or convertible designs, 2-in-1 laptops. Wi-Fi, Bluetooth. Wireless connectivity for internet access and peripheral devices. Number 2, tablets. Hardware overview. Tablets are portable devices that combine the functionality of a computer with the mobility of a smartphone. Tablets use touchscreens for input and often rely on wireless connections for internet access. Key components. Processor. Tablets use ARM-based processors like Apple's A-series chips or Qualcomm's Snapdragon processors that are highly efficient for mobile applications. RAM and storage. Tablets have RAM similar to smartphones, with storage typically ranging from 32 GB to 512 GB, depending on the model. Display. Tablets are equipped with high-resolution touchscreens, LED, OLED, or IPS, that support multi-touch gestures. Battery. Tablets have rechargeable lithium-ion batteries that allow for all-day usage. Cameras. Most tablets come with front and rear cameras for taking photos, video conferencing, and scanning documents. Wi-Fi, Bluetooth. Tablets offer wireless connectivity options for internet browsing, streaming, and device pairing. Other features: touchscreen input. Tablets rely on capacitive touchscreens, supporting finger gestures such as pinch to zoom and swipe for navigation. Connectivity ports. Many tablets only offer a charging port, USB-C or Lightning on Apple devices, but some higher-end tablets may offer additional ports such as USB-C or HDMI. Operating system. Tablets run on mobile operating systems like iOS, Android, or Windows, with a focus on apps optimized for touch interfaces. Number 3, smartphones. Hardware overview. Smartphones are the most ubiquitous mobile devices, combining communication tools with computing power. Understanding their hardware is key for effective troubleshooting and repair. Key components: processor, SoC. Smartphones are powered by System on Chips, SoC, which integrate multiple components, such as the CPU, GPU, graphics processing unit, and modem, into a single chip. Popular SoCs include Qualcomm Snapdragon, Apple A-Series, and Samsung Exynos. RAM and storage. Smartphones typically feature between 2 GB and 16 GB of RAM, depending on the model. Storage ranges from 32 GB to 1 TB in high-end models, with options for expandable storage, micro SD cards on some Android phones. Display. Smartphones use high-definition displays, including OLED or AMOLED technology for vibrant colors and deep blacks. Screen sizes typically range from 5 to 7 inches. Batteries. Batteries in smartphones are typically lithium-ion and offer anywhere from 8 to 20 hours of use depending on the device's energy consumptions. Cameras. Front and rear cameras are one of the main features of smartphones, with capabilities ranging from basic photos to 4K video recording and advanced AI-powered photography. Wi-Fi, Bluetooth. Smartphones rely on wireless communication for internet access, Bluetooth for peripherals like headsets and smartwatches, and NFC for mobile payments. Other features: fingerprint scanner, Face ID. Many smartphones now come with biometric security features for unlocking the phone. Sensors. Modern smartphones are equipped with a range of sensors, including accelerometers, gyroscopes, ambient light sensors, and proximity sensors, enabling a range of applications like step tracking and screen rotation. Troubleshooting common mobile issues. As a technician, troubleshooting mobile devices efficiently is crucial. Let's walk through common issues faced with laptops, tablets, and smartphones, along with their solutions. Number 1, laptops. Common issues and solutions. Laptop won't turn on. Troubleshooting. Check if the laptop is plugged in or if the battery is charged. Try a different power outlet and confirm that the power adapter is working. If using a removable battery, try removing and reinserting it. Overheating. Troubleshooting. Overheating may be caused by clogged vents or a failing cooling fan. Clean out dust with compressed air and ensure the fan is running correctly. Keep the laptop on a flat, hard surface to allow for proper airflow. Display issues. Troubleshooting. If the screen is black, try connecting the laptop to an external monitor to rule out a faulty screen. If the display is distorted, check the graphics drivers and update them if necessary. Number 2, tablets. Common issues and solutions. Frozen screen. Troubleshooting. If the tablet freezes, press and hold the power button for 10 to 20 seconds to force a restart. For Android, use the volume button and power button simultaneously. For iOS, use the volume up and power button combination to restart. Wi-Fi connectivity issues. Troubleshooting. Ensure that Wi-Fi is enabled and within range. Try restarting the router and tablet, and check for software updates. Touchscreen not responding. Troubleshooting. Clean the screen with a microfiber cloth to remove any dirt or debris. If the touchscreen still doesn't work, try restarting the device. A factory reset may be necessary if the issue persists. Number 3, smartphones. Common issues and solutions. battery draining quickly. Troubleshooting. Check battery usage in the settings to identify any apps consuming excessive power. Disable background app refresh. Lower screen brightness and switch to power-saving mode if necessary. Slow performance. Troubleshooting. Clear the cache. Remove unused apps or reset the phone to factory settings. Ensure there is enough free storage available, as a nearly full device can slow down performance. Camera not working. Troubleshooting. Restart the device and check for app updates. If the issue persists, clear the camera's app's cache or perform a factory reset if necessary. Laptops, tablets, and smartphones are all portable computing devices with their own unique hardware components designed for mobility and efficient performance. Common mobile issues include power failures, slow performance, display issues, and connectivity problems, all of which can be diagnosed and solved with the right troubleshooting techniques. Understanding the hardware of mobile devices and knowing how to fix common issues will make you a proficient IT technician and help you excel in the CompTIA A+ exams. Chapter 5. Virtualization and Cloud Computing. In today's IT world, virtualization and cloud computing are critical technologies that allow organizations to optimize resources, reduce costs, and improve scalability. As a CompTIA A+ technician, understanding how virtualization works and how cloud services are deployed will be essential to your role in managing and troubleshooting modern IT infrastructures. This chapter will introduce you to the basics of virtual machines and give you an overview of cloud computing and its services. Basics of virtual machines. Virtualization is the process of creating a virtual rather than physical version of a resource, such as a server, storage device, or network. In the context of computers, a virtual machine VM is a software-based emulation of a physical computer that runs an operating system and applications just like a physical computer would. Number 1. What is virtualization? Virtualization allows multiple virtual instances of operating systems, OS, to run on a single physical machine called the host machine. Each virtual machine, called a guest machine, operates independently and is allocated a portion of a host machine's resources, a CPU, memory, and storage. Virtualization improves resource utilization and provides flexibility in managing IT environments. Number 2, types of virtualization. There are several types of virtualization used in IT environments, including server virtualization, dividing a physical server into multiple virtual servers, each running its own OS and applications. This maximizes the use of hardware and reduces energy and hardware costs. Desktop virtualization, running desktop environments on a virtual machine, allowing users to access their work environments from various devices such as laptops, smartphones, or thin clients. Storage virtualization, combining physical storage devices into a single virtualized storage system. This is often used in data centers to provide more efficient storage management. Network virtualization, abstracting network resources such as switches and routers to create virtual networks that can be managed independently from physical hardware. Number 3, how virtual machines work. Each virtual machine runs an operating system, which can be different from the host OS and is allocated virtual hardware resources such as CPU, memory, disk space, and network interfaces. The hypervisor is the key component that manages the VMs. Type 1 hypervisor, bare metal. This hypervisor runs directly on the host hardware. It is typically used in enterprise environments for maximum performance. Examples include VMware XSXi and Microsoft Hyper-V. Type 2 hypervisor, hosted. This hypervisor runs on top of an existing operating system. It's typically used for personal or testing purposes. Examples include VMware Workstation and Oracle VirtualBox. Number 4, benefits of virtualization. Resource efficiency. Multiple virtual machines can run on a single physical server, reducing hardware costs and power consumption. Isolation. Each VM is isolated from others, ensuring that issues in one VM don't affect others. Scalability. Virtual machines can be easily added or removed to accommodate workload changes, offering high flexibility. Disaster recovery. VMs can be easily backed up, replicated, and restored, making disaster recovery more efficient. Number 5, use cases of virtual machines. Running multiple OSs. Virtual machines allow you to run different operating systems on the same machine. For example, running Linux on a Windows computer. Testing and development. Developers and IT professionals use VMs to test software or configurations in isolated environments before deploying them to production systems. Cloud hosting. Virtual machines are used by cloud service providers to host virtualized instances of servers for customers. Introduction of cloud services. Cloud computing is a delivery of computing services over the Internet, such as storage, processing power, networking, and software, rather than relying on local hardware and infrastructure. Organizations and individuals can leverage the power of cloud providers to access computing resources on demand. Number 1, what is cloud computing? Cloud computing allows users to access computing resources and services remotely, typically via the Internet. This eliminates the need for businesses and individuals to maintain their own physical servers and infrastructure. Cloud services can be accessed via web browsers or specific apps, offering convenience and scalability. Number 2, types of cloud services. Cloud computing is typically divided into 3 main service models, each serving different needs and offering varying levels of control over the infrastructure. Infrastructure as a Service, IaaS. The most fundamental cloud service model, IaaS, provides virtualized computing resources over the Internet. With IaaS, users can rent virtual machines, storage, and networks without the need to manage physical hardware. Examples of IaaS providers include Amazon Web Service, AWS, Microsoft Azure, and Google Cloud Platform, GCP. Use case. Organizations use IaaS for hosting websites, running applications, or setting up virtualized environments. Platform as a Service, PaaS. PaaS provides a platform for developing, testing, and deploying applications. It includes infrastructure like servers and storage, as well as tools and services, databases, programming languages, application frameworks that make it easier for developers to build software. Examples of PaaS include Google App Engine, AWS Elastic Beanstalk, and Microsoft Azure App Services. Use case: developers use PAS to focus on writing code and deploying applications without worrying about managing the underlying infrastructure. Software as a Service, SaaS. SaaS delivers fully functional software applications via the Internet, eliminating the need for users to install or maintain software locally. SaaS is typically subscription-based and can be accessed through a browser or dedicated app. Examples include Google Workspace, Docs, Sheets, Gmail, Microsoft 365, and Salesforce. Use case: businesses use SaaS for customer relationship management, CRM, email services, and office productivity tools. Number 3, cloud deployment models. Cloud services can be deployed in various models depending on the level of control and security required. Public cloud. In the public cloud model, cloud services are delivered over the Internet and shared by multiple customers, tenants. These services are hosted and managed by a third-party provider. Examples include AWS, Microsoft Azure, and Google Cloud. Use case: ideal for small to medium-sized businesses or individuals who need scalable resources without maintaining their own infrastructure. Private cloud. In the private cloud model, cloud services are used by a single organization and can be hosted on premises or by a third-party provider. This model offers more control and security. Use case: used by large enterprises or organizations with specific compliance and security requirements. Hybrid cloud. The hybrid cloud model combines elements of both public and private clouds. It allows data and applications to be shared between them, offering greater flexibility and deployment options. Use case: organizations use hybrid clouds to maintain sensitive data in a private cloud while leveraging the scalability of the public cloud for other workloads. Number 4, benefits of cloud computing. Cost savings. Cloud computing eliminates the need for significant upfront investment in hardware and software. You pay for only the services you use, pay as you go. Scalability. Cloud services can scale up or down based on demand, making it easy to accommodate fluctuating workloads. Accessibility. Cloud services are accessible from anywhere with an internet connection, enabling remote work and access to data across multiple devices. Reliability. Major cloud providers offer robust infrastructure with high availability and built-in redundancy to ensure minimal downtime. Number 5, cloud security. While cloud services offer numerous advantages, security is always a concern. It is essential for cloud services to understand their responsibilities for securing their data and applications. Key security practices include the following: encryption, ensuring that data is encrypted during transmission and at rest. Authentication and access control. Using multi-factor authentication, MFA, and role-based access controls, RBAC, to limit access to sensitive data and systems. Regular backups, ensuring that data is regularly backed up to avoid data loss in the event of a failure. Virtualization allows for the efficient use of resources by running multiple virtual machines on a single physical machine, reducing costs and improving flexibility. Virtualization is used in environments such as server hosting, testing, and cloud infrastructures to optimize operations. Cloud computing provides a range of on-demand services from infrastructure, IaaS, to software, SaaS, making it easier for organizations to scale their IT needs without maintaining physical infrastructure. Cloud deployment models include public, private, and hybrid clouds, offering different levels of control and flexibility based on the organization's needs. While cloud computing offers many benefits, it's important to implement best practices in security to protect data and ensure privacy. Chapter 6: Troubleshooting Hardware and Network Problems. As an IT professional, troubleshooting is one of the most important skills you will develop. Whether you're working with hardware or network issues, the ability to systematically diagnose and resolve problems is essential. In this chapter, we will guide you through step-by-step troubleshooting models that can be applied to various hardware and network issues. We will also present real-life scenarios to help you become familiar with common problems and their solutions. Step-by-step troubleshooting models. Troubleshooting hardware and network problems requires a structured approach to identify and resolve issues efficiently. A solid troubleshooting model will help you break down complex problems into manageable steps. Here are some of the most effective models you can follow when troubleshooting. Number 1, the CompTIA troubleshooting method. The CompTIA troubleshooting method is a structured, logical approach designed to isolate and fix problems quickly and efficiently. Here are the steps involved. Step 1, identify the problem. Gather information. Start by gathering as much information as possible about the issue. Ask the user for a detailed description of the problem, including when it started, whether it's affecting specific software or hardware, and any recent changes to the system. Verify the issue. If possible, replicate the problem yourself to understand it better. Step 2, establish a theory of probable cause. Based on the information gathered, develop a hypothesis about what might be causing the issue. For example, if the user reports that the computer is running slow, you might suspect a performance issue due to a lack of storage or memory. Use knowledge. Rely on your knowledge of IT systems and troubleshooting techniques. You can also consult manuals, online resources, or other team members if necessary. Number 3, test the theory. Once you have a theory, test it by performing diagnostic tests or checks. If you suspect a faulty RAM module, for example, run a memory diagnostic tool or physically swap out the memory to test your theory. Eliminate possibilities. If your first theory does not solve the problem, go back to step 2 and develop a new theory. Step 4, establish a plan of action. After testing your theory, develop a plan of action to resolve the issue. If you determine that the problem is a faulty hard drive, you might need to replace it, recover data, and reinstall the operating system. Step 5, implement the solution. Once you have an action plan, implement the solution. Be sure to document each step and make backups if necessary, especially when working with data. Communicate with the user. Inform the user of what steps you will take and what to expect during the process. Step 6, verify system functionality. After the solution has been implemented, test the system to make sure the issue has been resolved. Ensure that the system is working properly and that the user's needs have been met. Ask for user feedback. After verifying that the problem is resolved, Ask the user to confirm that the system is functioning correctly. Number 7, document the process. Finally, document the entire troubleshooting process. Record the problem, the steps taken, and the final solution for future reference. Documentation is crucial for keeping track of recurring issues and solutions. Number 2, the OSI model for network troubleshooting. When troubleshooting network problems, understanding the OSI, Open Systems Interconnection, the model can be incredibly helpful. The OSI model is a conceptual framework used to describe network communication in 7 layers. By isolating problems in specific layers, you can narrow down the cause and resolve the issue more efficiently. Level 1, physical layer, deals with hardware connections like cables, routers, and switches. If there's no connectivity, check cables, routers, and network cards. Layer 1, physical layer, deals with hardware connections like cables, routers, and switches. If there's no connectivity, check cables, routers, and network cards. Layer 2, data link layer, concerns the communication between devices within a network, such as the MAC addresses. Check if devices are connected to the correct network and that there are no issues with network interfaces. Level 3, network layer, includes IP addressing and routing. Issues here might be caused by incorrect IP addresses, subnet masks, or routing configurations. Check the IP configuration, DNS settings, and routing tables. Layer 4, transport layer, handles end-to-end communication and error recovery. Issues here might involve protocol configuration or port blocking. Layer 5, session layer, manages sessions between applications. Troubleshoot here for issues with applications or network session conflicts. Layer 6, presentation layer, ensures data is in a usable format. This layer is often concerned with encryption or compression. Layer 7, application layer, deals with software applications. Application-level problems can often be resolved by checking settings, credentials, and configurations. Real-life scenarios and common issues. To better illustrate how troubleshooting works in real-life scenarios, let's go through some common hardware and network issues and their possible solutions. Number 1, Scenario 1, computer won't boot. Problem: a user reports that their computer doesn't start after pressing the power button. The screen remains black, and there's no sound of the hard drive spinning. Step-by-step troubleshooting. Step 1, gather information. Has there been any recent change to the system, for instance, power surge or hardware upgrade? Step 2, theory. The issue could be a failed power supply, a faulty motherboard, or a loose connection. Step 3, test. Check the power supply by testing it with a multimeter. If possible, test the power supply in another computer. Step 4, plan of action. If the power supply is the issue, replace it with a working unit. Step 5, implement the solution. Replace the power supply and verify that the system boots correctly. Step 6, verify functionality. Confirm that the system powers on and operates normally. Step 7, document the issue and solution. Number 2, Scenario 2, network connectivity issues. Problem: a user reports that they cannot connect to the internet, even though other devices on the same network can access it. Step-by-step troubleshooting. Step 1, gather information. What type of device is the user using? A PC, a laptop, or mobile? Are there any recent changes to the network configuration or device? Step 2, theory. The issue could be caused by incorrect IP settings, a faulty network adapter, or issues with the router. Step 3, test. Check the device's IP settings. Use ipconfig on Windows or ifconfig on Mac OS or Linux to verify the IP address. Test the network cable or Wi-Fi connection. Step 4, plan of action. If the network adapter is faulty, replace it and reinstall the network drivers. Step 5, implement the solution. After fixing the IP settings or replacing the network adapter, reconnect the device to the network. Step 6, verify functionality. Test connectivity to the Internet by opening a web page or pinging an external server. Step 7, document the issue and solution. Number 3, Scenario 3, slow computer performance. Problem. A user complains that their computer is running very slow, even though no new programs have been installed recently. Step-by-step troubleshooting. Step 1, gather information. What kind of task does the user perform? Is the issue persistent or intermittent? Step 2, theory. The issue could be caused by a lack of available storage, too many background processes, or insufficient RAM. Step 3, test. Check Task Manager on Windows or Activity Monitor on Mac OS to see if any applications are consuming excessive CPU or memory resources. Step 4, plan of action. Clean up temporary files, disable unnecessary startup programs, or add more RAM if required. Step 5, implement the solution. Free up disk space and disable unnecessary programs. If necessary, install additional memory. Step 6, verify functionality. Check the system's performance after the cleanup or upgrade. Step 7, document the issue and solution. Structured troubleshooting models are essential for efficiently identifying and resolving issues. The CompTIA troubleshooting method and OSI model provide effective frameworks for diagnosing problems in both hardware and network environments. Common hardware issues include power failure, booting issues, and performance degradation, which can often be resolved by testing components and performing diagnostic checks. Network problems such as connectivity issues and slow speeds can be diagnosed using systematic steps, such as checking IP configurations, network cables, and hardware components. Real-life troubleshooting scenarios help to develop practical skills in problem-solving, which are essential for successfully passing the CompTIA A+ exams and excelling in IT support roles. Chapter 7, Operating Systems Essentials. Operating systems, OS, are the backbone of any computing device. Whether you're working with personal computers, servers, or mobile devices, understanding the essentials of different operating systems, OS, is a fundamental skill for any IT professional. This chapter will introduce you to the core concepts of the most common operating systems you'll encounter in IT environments: Windows, Mac OS, and Linux. Additionally, we will cover installation, updates, and recovery tools that you will need to know to keep systems running smoothly. Windows, Mac OS, and Linux overview. Number 1, Windows operating system. Windows is one of the most widely used operating systems in the world, especially in enterprise environments. Microsoft's Windows OS offers user-friendly interfaces and strong compatibility with a wide range of hardware and software. Versions of Windows: Windows 10, one of the most popular versions, known for its user-friendly interface and solid integration with various applications and services. Windows 11, the latest iteration of Windows, offering a modernized UI with features like virtual desktops, updated window management, and better support for newer hardware. Windows Server, a specialized version designed for use in server environments, offering features such as Active Directory, file and print services, and web server management. Windows Interface. The desktop is composed of the Start menu, taskbar, File Explorer, and Control Panel settings. The Start menu is used for accessing programs and settings, while the taskbar allows you to quickly switch between running applications. File System. Windows typically uses the NTFS, New Technology File System, for storing files, with support for large files and advanced security features. Number 2, Mac OS operating system. Mac OS is the operating system used on Apple's line of computers, MacBook, iMac, Mac Pro, etc. Known for its sleek design and high performance, Mac OS offers a smooth user experience with seamless integration with other Apple devices. Versions of Mac OS. Mac OS Ventura, the latest version, featuring new privacy and security tools, a redesigned system settings menu, and improved focus on user productivity. Mac OS Monterey and Big Sur. These versions bring significant performance improvements and UI updates. Mac OS Interface. The user interface of Mac OS is clean and intuitive. The dock provides quick access to applications, and the Finder app helps users manage files and folders. File System. Mac OS uses the APFS, Apple File System, a modern file system designed to improve performance and security, particularly for SSDs. Number 3, Linux operating system. Linux is an open-source operating system that is widely used in server environments, embedded systems, and as a development platform. It's highly customizable, offering users full control over the OS, which makes it popular among developers, system administrators, and tech enthusiasts. Distributions. Unlike Windows and Mac OS, Linux is not a single operating system, but rather a collection of distributions, distros. Some of the most popular distributions include the following. Ubuntu, one of the most user-friendly Linux distributions, ideal for newcomers to Linux. CentOS, now Rocky Linux, popular in enterprise environments, especially for servers. Debian, known for stability, often used as a foundation for other distros like Ubuntu. Linux interface. Linux can be controlled via a command line interface, CLI, or through a graphical user interface, GUI. Depending on the distribution, Linux provides the flexibility to operate as either a headless server or a fully functional desktop system. File system. Linux commonly uses ext4, fourth extended file system, but it also supports a variety of other file systems such as XFS, BTRFS, and NTFS for compatibility with Windows. Installation, updates, and recovery tools. Understanding how to properly install, update, and recover an operating system is crucial for IT professionals. Here, we will walk through the key tools and processes you need to know for Windows, Mac OS, and Linux. Number 1, Windows installation and updates. Installing Windows. Using installation media. Windows can be installed from a bootable USB drive, DVD, or other network. The Windows Installation Media Creation tool allows you to create a bootable installation USB. Once you boot from the USB, follow the on-screen instructions to select the partition, format it if necessary, and complete the installation. Activation. A valid product key is required to activate Windows, ensuring that the copy of the operating system is legitimate. Windows Updates. Windows Update. The primary tool for managing updates in Windows is Windows Update. It automatically downloads and installs updates for the OS, security patches, drivers, and other system components. You can access it via the Settings, Update, and Security menu. Types of updates. These include security updates, feature updates, and driver updates. Window Update ensures that the system is up to date and protected from the latest vulnerabilities. Update Troubleshooter. If updates are failing to install, Windows provides a built-in troubleshooter that can help identify and fix issues related to updating. Windows Recovery Tools. System Restore allows you to roll back your system to a previous state using restore points. This can be helpful if a recent update or software installation causes problems. Startup Repair. If Windows is not booting properly, you can use Startup Repair from the Advanced Startup options to automatically diagnose and fix issues. Reset the PC. A powerful recovery option that allows you to reset your PC to its factory settings, either keeping or removing your personal files. Number 2, Mac OS installation and updates. Installing Mac OS. Using Mac OS Recovery, Mac OS can be reinstalled using the built-in Mac OS Recovery tool. This tool can be accessed by restarting the Mac and holding Command+R during startup. App Store installation. For updates and upgrades, Mac OS uses the App Store to download and install the latest version of the OS. External installation. Mac OS can also be installed from a bootable USB drive created using the Mac OS Recovery or disk utility. Mac OS updates. Software update. Mac OS uses the Software Update tool, located under System Preferences, Software Update, to check for and install updates. Apple provides security updates, Mac OS upgrades, and app updates through this tool. Automatic updates. You can set Mac OS to automatically download and install updates to keep the system up to date with security patches and new features. Mac OS Recovery Tools. Disk Utility. Used to repair disk permissions, format drives, or create disk images. Time Machine. A built-in backup feature that allows users to restore files and system stats from backups. Mac OS Recovery includes tools for reinstalling Mac OS, accessing disk utility, or restoring from Time Machine. Number 3, Linux installation and updates. Installing Linux. Live USB DVD. Linux is typically installed from a bootable USB drive or DVD. Most distributions provide an ISO image that you can burn into a USB drive using tools like Rufus or UNetbooten. Partitioning. During installation, you will need to partition the hard drive, select the file system such as ext4, and choose whether to install Linux alongside another OS or as the only OS. Graphical and text-based installers. Most Linux distributions offer graphical installers, while some advanced users may prefer using the command line. Linux updates, package managers. Linux distributions use package managers to manage system updates and software installation. Common package managers include the following: apt, Debian, Ubuntu-based systems, sudo app update and sudo app upgrade, yum, CentOS Red Hat-based systems, sudo yum update, DNF Fedora-based systems, sudo DNF update, Zyper OpenSUSE-based systems, sudo Zyper update. Kernel updates. In addition to regular software and security updates, Linux systems also can do the update with the Linux kernel for performance improvements and hardware support. Linux recovery tools. Grub, Grand Unified Bootloader. The bootloader used by most Linux distributions. If the system does not boot, you can use Grub to access recovery options and troubleshoot boot issues. Rescue mode. Many Linux distributions offer a rescue mode in their boot menu, allowing you to access the system and run diagnostic tools or fix broken installations. Live CD USB. A bootable Linux Live USB can be used to recover data, repair partitions, or reinstall the OS if needed. Windows, Mac OS, and Linux each have unique characteristics, but all require essential skills for installation, updates, and recovery. Windows is known for its widespread use in business and home environments, with tools like Windows Update and System Restore to maintain and recover the system. Mac OS offers a seamless experience with Mac OS Recovery and Time Machine for recovery, alongside the App Store for updates. Linux is highly customizable and often used in server environments, with various package managers and Grub for recovery. Chapter 8. Software Troubleshooting. In the world of IT support, one of the most common tasks you'll face is troubleshooting software issues. Whether it's a slow system, application errors, or crashes, understanding the root causes and knowing how to diagnose and resolve them quickly is essential for providing top-notch support. In this chapter, we will explore two of the most common software troubleshooting scenarios: troubleshooting slow systems and crashes, and resolving application errors. Troubleshooting slow systems and crashes. A slow system or unexpected crashes can be incredibly frustrating for users. These issues can have many causes, ranging from resource-heavy applications to corrupt system files or outdated drivers. Here are some common issues that can cause a system to slow down or crash, along with troubleshooting steps to address them. Number 1. Identifying causes of slow systems. Systems can become slow for several reasons. As an IT professional, your job is to narrow down the issue and find the solution. Overloaded system resources. When too many applications or processes are running, the system's CPU, memory, or disk resources may become overloaded. Diagnostic tool. Use Task Manager on Windows or Activity Monitor on Mac OS to identify processes consuming excessive CPU or memory. Solution. Close unnecessary applications or processes. You can also disable unnecessary startup programs to free up resources. Low storage space. If a system's storage drive, HDD or SSD, is nearly full, it can significantly affect system performance. Diagnostic tool. Check disk usage using File Explorer for Windows or Finder for Mac OS. Look for large files or folders that can be deleted or moved to an external drive. Solution: clean up the disk by removing old files, uninstalling unnecessary applications, and using built-in cleanup tools like Disk Cleanup on Windows or Storage Management on Mac OS. Fragmented hard drive, HDD. Fragmentation occurs when files are scattered across the hard drive, which can slow down read and write operations. Diagnostic tool. On Windows, run defragment and optimize drives. For Mac OS, fragmentation is not typically a concern due to the use of APFS, but the disk can still be cleaned or repaired using Disk Utility. Solution: run the defragmentation tool on HDDs to optimize file placement. Consider upgrading to an SSD, as SSDs are not affected by fragmentation. Outdated drivers or software. Running outdated drivers, especially graphics or chipset drivers, can cause performance problems. Diagnostic tool. Check for driver updates using Device Manager on Windows or System Preferences, Software Update on Mac OS. Solution: update the drivers for the GPU, chipset, network adapter, and other components. Additionally, ensure that the OS and key applications are updated. Too many background processes. Some applications run processes in the background that consume resources even when the main application isn't in use. Diagnostic tool. In Task Manager Windows or Activity Monitor for Mac OS, check the Processes tab to identify which background processes are using system resources. Solution: disable or remove the unnecessary background processes. For Windows, you can use msconfig or Task Scheduler to disable unnecessary startup items. Number 2, troubleshooting system crashes. System crashes, often referred to as blue screen of death or BSOD in Windows, can occur for various reasons, including hardware failure, software conflicts, or corrupt system files. Corrupt system files. Corrupt or missing system files can cause crashes or unexpected restarts. Diagnostic tool. Use System File Checker, SFC, on Windows or Disk Utility on Mac OS to scan and repair system files. Solution: on Windows, run SFC, Scan Now, in Command Prompt as an administrator. If corruption is found, the tool will attempt to repair the system files. Faulty hardware. Sometimes system crashes are caused by failing hardware, such as RAM, CPU, or storage devices. Diagnostic tool. Use memory diagnostic tools like Windows Memory Diagnostic or third-party tools to check the RAM for errors. Tools like Crystal Disk Info can check the health of a storage device. Solution: replace faulty hardware such as memory modules or hard drives. Overheating. Overheating can cause the CPU or GPU to throttle performance or shut down to protect the hardware. Diagnostic tool. Use temperature monitoring software such as Core Temp for Windows or iStat menus for Mac OS to monitor the temperature of key components. Solution: ensure that the cooling system is working correctly, clean dust from fans, or consider upgrading the cooling system if overheating persists. Driver conflicts. Sometimes new drivers or updates can conflict with existing drivers, causing system crashes. Diagnostic tool. Use Device Manager for Windows or console Mac OS to check for hardware conflicts or yellow exclamation marks indicating driver problems. Solution: roll back the problematic driver, update to the latest version, or uninstall the driver and reinstall it. Application errors and solutions. Application errors can vary from minor glitches to critical failures that cause the application to crash. As an IT professional, you need to know how to diagnose and resolve these errors to ensure that users can work efficiently without interruption. Number 1, identifying application errors. Application errors can stem from several issues, including software bugs, misconfigurations, or compatibility problems. Corrupt application files. If the installation files or application data are corrupt, the program might not function as intended. Diagnostic tool. Look for error messages or logs that might indicate missing or corrupt files. Solution: reinstall the application to ensure that all necessary files are in place. Consider using tools like Windows Repair Option for UWP apps or Mac OS reinstallation from the App Store. Software compatibility issues. Older applications may not be compatible with newer operating systems, leading to errors or crashes. Diagnostic tool. Check the application's compatibility settings. On Windows, right-click the executable and choose Properties, Compatibility. Solution: run the program in compatibility mode for older versions of Windows. Or update the application to the latest version that supports the current OS. Insufficient resources. If the system doesn't have enough memory or CPU power to run an application, it can cause errors, slowdowns, or crashes. Diagnostic tool. Monitor the system's CPU and memory usage in Task Manager or Activity Monitor. Solution: close other applications that are consuming excessive resources. If necessary, increase the system's memory or upgrade hardware. Number 2, resolving common application errors. Error message: application has stopped working. Diagnostic tool. Check for crash reports in Event Viewer, which is Windows, or Console, which is in Mac OS. Solution: check the application system requirements and make sure your system meets those requirements. Also, try reinstalling the application or updating to the latest version. Error message: file not found or missing DLL. Diagnostic tool. Ensure the required files are in the correct locations. On Windows, use System File Checker to check for missing or corrupted system files. Solution: if necessary, download and replace the missing DLL files or reinstall the application to restore them. Error message: out of memory. Diagnostic tool. Use Task Manager or Activity Monitor to identify which application is consuming excessive memory. Solution: choose other programs and consider adding more RAM if the issue is persistent. Slow systems can often be resolved by closing unnecessary processes, cleaning up storage, updating drivers, and upgrading hardware if needed. System crashes may be caused by corrupt files, faulty hardware, overheating, or driver conflicts. Use diagnostic tools to identify and resolve the issue. Application errors can result from corrupted files, compatibility issues, or insufficient system resources. Reinstalling the application or updating drivers may resolve these errors. Regular system maintenance, including software updates, disk cleanup, and memory management, is essential for preventing software-related issues from occurring in the future. Chapter 9. Security Fundamentals. Security is one of the most critical aspects of IT. In today's increasingly digital world, understanding how to safeguard both devices and networks from malicious threats is essential. From malware and ransomware to phishing scams, IT professionals must be equipped with the knowledge and tools to protect systems and sensitive data. In this chapter, we'll discuss the fundamentals of security, common threats, best practices for securing devices and networks, and the tools you can use to enhance protection. Understanding threats, malware, ransomware, and phishing. Threats to IT systems are continuously evolving, with cyber criminals using increasingly sophisticated methods to compromise data and systems. Understanding these threats is crucial for defending against them. Number 1. Malware, malicious software. Malware refers to any type of malicious software that is designed to harm or exploit a device or network. It includes viruses, worms, trojans, spyware, and adware. Types of malware. Viruses, programs that infect other software or files and spread to other systems. Worms, self-replicating programs that spread over networks without user intervention. Trojans, malware disguised as legitimate software, often used to gain unauthorized access to systems. Spyware, software that secretly monitors and records user activities, typically to steal sensitive information. Adware, software that automatically delivers unwanted ads and is often bundled with other applications. How malware spreads. Email attachments. Malware can be delivered through email attachments that users mistakenly open. Infected websites. Visiting a compromised or malicious website can automatically download malware onto a device. Removable media. Flash drives or external hard drives can carry malware from one system to another. Prevention and protection. Antivirus software. Use antivirus and anti-malware tools to scan and remove malware from devices. Regular updates. Keep operating systems and software up to date with security patches. Safe browsing practices. Avoid visiting unknown or suspicious websites, and don't open email attachments from untrusted sources. Number 2, ransomware. Ransomware is a type of malware that encrypts a user's files or locks them out of the system, demanding payment, usually in cryptocurrency, for the decryption key or access to the system. How ransomware works. Encryption. Once the ransomware infects the system, it encrypts files with strong encryption algorithms, making them inaccessible to the user. Demand for payment. The attacker demands payment in exchange for the decryption key, threatening to delete the files if the ransom isn't paid. Ransomware vectors. Email phishing, often delivered through malicious attachments or links in phishing emails. Exploit vulnerabilities. Attackers may exploit security holes in software to gain access to systems and deploy ransomware. Prevention and protection. Backups. Regularly back up important data to an external device or cloud storage that is not connected to the network. Email filtering. Use email filtering tools to block suspicious attachments and links. Endpoint protection. Install endpoint security software that can detect and block ransomware threats before they encrypt files. Number 3, phishing. Phishing is a social engineering attack where cyber criminals impersonate legitimate entities such as banks, email providers, or service companies to trick individuals into revealing sensitive information such as usernames, passwords, or financial details. Common phishing techniques. Email phishing. Fake emails that look like they're from trusted sources asking for personal or financial information. Spear phishing. Targeted phishing where attackers research the victim to craft personalized messages. Vishing. Voice phishing where attackers use phone calls to trick individuals into providing sensitive information. Smishing. Phishing conducted via SMS text messages, typically containing malicious links or asking for personal details. How to spot phishing attempts. Suspicious email addresses. Look out for emails from addresses that seem unusual or have misspellings. Urgent language. Phishing emails often include urgent requests such as immediate action required or account suspended. Unsolicited links. Don't click on links or open attachments in unsolicited emails. Spelling and grammar mistakes. Professional organizations rarely send emails with significant errors. Prevention and protection. Be skeptical. Always verify the source of an email or message before responding. Two-factor authentication. Enable two-factor authentication on important accounts to add an extra layer of security. Educate users. Regularly train employees or users on how to identify phishing attacks and what to do if they suspect a phishing attempt. Best practices for device and network security. Securing devices and networks requires a combination of preventive measures, monitoring, and quick responses to potential threats. Here are some best practices for ensuring the security of both individual devices and organizational networks. Number 1, device security. Securing individual devices like laptops, desktops, mobile devices, that's the first line of defense against cyber threats. Use strong passwords. Always set strong, unique passwords for devices, accounts, and applications. Consider using a password manager to securely store passwords. Enable full disk encryption. Encrypt sensitive data on devices using tools like BitLocker for Windows or File Vault for Mac OS. Enable automatic software updates. Ensure that all operating systems and applications are regularly updated to fix vulnerabilities. Install antivirus and anti-malware software. Use reputable antivirus software to detect and block threats. Keep these programs updated regularly. Use firewalls. Enable firewalls on both personal and business devices to monitor incoming and outgoing network traffic for malicious activity. Number 2, network security. Securing your network involves protecting both the physical and wireless infrastructure from unauthorized access, attacks, and intrusions. Use strong Wi-Fi encryption. Always use WPA3 encryption on Wi-Fi networks to prevent unauthorized access. Disable WPS, which is Wi-Fi protected setup, as it's often vulnerable to attacks. Implement network segmentation. Separate critical systems and sensitive data from less secure devices, like using VLANs or firewalls, to limit the impact of an attack. Monitor network traffic. Use network monitoring tools to detect unusual activity that could indicate a potential threat. secure routers and modems. Change the default username and password on routers and modems. Regularly check for firmware updates to fix security vulnerabilities. Use VPNs for remote access. When accessing a network remotely, use a virtual private network, VPN, to encrypt the connection and ensure privacy. Using security tools and software. To effectively protect devices and networks, IT professionals rely on a wide range of security tools and software that provides real-time protection, system monitoring, and vulnerability scanning. Number 1, antivirus and anti-malware software. Antivirus programs. These programs detect, quarantine, and remove viruses, worms, and other malicious software from systems. Popular tools: Norton, McAfee, Kaspersky, Bitdefender. Anti-malware tools. These tools focus on detecting and removing malware that may not be classified as a virus, like spyware, adware, Trojans. Popular tools: Malwarebytes, Spybot Search and Destroy, AdWCleaner. Number 2, firewalls. Software firewalls. These firewalls are installed on devices and monitor the incoming and outgoing traffic to block unauthorized access. Most operating systems, like Windows and Mac OS, come with built-in firewalls. Hardware firewalls. Used in business environments, these devices provide an additional layer of security to protect entire networks. Popular tools: Zone Alarm, Commodore Firewall, Glasswire. Number 3, encryption tools. Disk encryption encrypts the entire hard drive to protect data in case of theft or unauthorized access. Popular tools: BitLocker for Windows, FileVault, Mac OS, VeraCrypt, which is cross-platform. File encryption. For encrypting specific files or folders, popular tools are 7-Zip, AxCrypt, and Cryptomatter. Number 4, password managers. Password management. These tools securely store and encrypt passwords, helping users maintain strong, unique credentials for every account. Popular tools include LastPass, 1Password, Dashlane. Number 5, backup solutions. Backup software. Regular backups ensure that in case of a ransomware attack or data corruption, you can recover important files and systems. Popular tools: Acronis True Image, Macrium Reflect, and Backblaze. Malware, ransomware, and phishing are among the most common threats to systems and data. Understanding how they work and how to prevent them is key to IT security. Best practices for device and network security include strong passwords, regular updates, encryption, and network monitoring. Security tools like antivirus software, firewalls, and encryption tools are essential for protecting systems from cyber threats. Training and awareness for end users, along with ongoing vigilance, play an essential role in maintaining a secure environment. Chapter 10: Advanced Troubleshooting Techniques. In IT support, troubleshooting is a critical skill, and while basic issues can often be resolved with simple solutions, advanced problems may require a deeper understanding of both hardware and software. As systems become more complex and cybersecurity threats grow more sophisticated, knowing how to diagnose and solve complex issues is essential. This chapter will focus on advanced troubleshooting techniques for both operating systems and software, as well as advanced security threat mitigation strategies. Solving complex OS and software issues. When troubleshooting operating systems or software problems, the issues can often be more elusive or involve multiple layers of the system. Here, we will explore advanced techniques for diagnosing and resolving these types of issues. Number 1, solving OS boot problems. Issues that prevent an operating system from booting up are some of the most complex problems users can face. These can occur due to hardware failures, corrupt system files, or misconfigurations. Advanced troubleshooting techniques. Boot from recovery media. If the OS cannot boot normally, use recovery media such as a bootable USB drive or DVD to access repair tools. For Windows, use the Startup Repair tool available in the Advanced Startup options. For Mac OS, boot into Mac OS Recovery by holding Command+R at startup to run disk utility or reinstall Mac OS. Check for hardware issues. If the system fails to boot, it may be due to hardware failure such as a malfunctioning hard drive or RAM. Use tools like MemTest86 for memory testing or Crystal Disk Info for HDD SSD health checking. Fix corrupt system files. On Windows, use System File Checker, SFC, Scan Now to check and repair corrupt system files. On Linux, use FSCK to check file system integrity. Rebuild boot configuration. In case of a corrupted boot configuration, use tools like bootrec.exe Windows to repair the master boot record, MBR, or GRUB, Linux. That's to fix bootloader problems. Number 2, resolving driver issues. Driver issues are common causes of software malfunctions, crashes, or hardware not functioning properly. Advanced troubleshooting techniques. Check Device Manager for errors. In Windows, open Device Manager to look for warning symbols, yellow exclamation marks, indicating problematic or missing drivers. Use Event Viewer for error logs. In Windows, use Event Viewer to view detailed error logs that can help identify driver conflicts or failure. Update, rollback, or reinstall drivers. If a new driver update causes issues, use Device Manager to roll back the driver or reinstall it to resolve compatibility issues. Use Compatibility Mode. On Windows, if a driver is incompatible with the current version, try using Compatibility Mode to force the driver to run as if it's on an older OS version. Test hardware. If the device is still malfunctioning after troubleshooting drivers, use diagnostic tools like HW Monitor, that's for temperature and voltage readings, or Seagate C-Tools for hard drive diagnostics to test hardware functionality. Number 3, resolving software crashes and freezes. Frequent software crashes and freezes can disrupt user productivity. They can be caused by a variety of issues, including insufficient system resources, incompatible software, or corrupt files. Advanced troubleshooting techniques. Check for software conflicts. Use Task Manager or Activity Monitor to check which processes are using excessive resources and which programs might be conflicting. Use System Restore, Windows. If recent software installations have caused issues, you can use System Restore to return to a point before the problem began. Memory dumps and crash logs. Review Windows mini dumps or Mac crash reports for clues about the cause of software crashes. Tools like Blue Screen View, Windows, can analyze crash dump files to pinpoint the root cause. Uninstall and reinstall software. If a specific program keeps crashing, uninstall it completely, including residual files, and then reinstall it. Sometimes running the program as administrator can also help resolve permission-related issues. Check system resources. If the system is freezing, check if there's a lack of system resources like RAM and CPU. Use Task Manager for Windows or Activity Monitor for Mac OS. That's to identify resource hogs and close unnecessary applications. Number 4, resolving network issues. Network problems can range from slow internet speeds to complete connectivity loss. Diagnosing network issues involves checking both hardware and software configurations. Advanced troubleshooting techniques. Check IP configuration. Ensure that the device has a valid IP address, DNS settings, and gateway configuration. Use ipconfig Windows or ifconfig Linux and Mac OS to check network settings. Ping and trace route. Use ping to test connectivity to a remote server and trace route to trace the route packets taken across the network. This helps identify where the connection might be breaking down. Analyze network traffic. Use network analysis tools like Wireshark or TCP dump to capture and analyze packets. This can help detect abnormal traffic patterns or identify the source of network congestion. Check router and switch configurations. Ensure that routers and switches are properly configured. Reset or update firmware if necessary. Test physical connections. Use tools like cable testers to verify that cables are functioning correctly and check the integrity of network ports. Advanced security threat mitigation. As cyber threats continue to evolve, advanced security measures are essential for protecting both systems and sensitive data. This section will explore advanced techniques for mitigating various types of security threats, focusing on proactive prevention and effective response strategies. Number 1, mitigating malware and ransomware attacks. The key to defending against malware and ransomware is layered security, which combines multiple protective measures to prevent, detect, and mitigate attacks. Advanced mitigation techniques. Network segmentation. Segment your network to isolate critical systems and limit the spread of malware. For instance, if malware infects one system, network segmentation can contain the speed. Advanced Threat Detection Systems, IDS, IPS. Use Intrusion Detection Systems, IDS, and Intrusion Prevention Systems, IPS, to detect and block suspicious activity on the network in real time. Endpoint protection. Install and configure endpoint protection software, which not only detects malware, but also provides behavior-based detection to identify new, unknown threats. Ransomware recovery tools. Implement ransomware-specific defense tools such as Clance, Sophos InterceptX, or CrowdStrike, which can help detect and prevent ransomware encryption processes. Regular backups and offline storage. Use an automated backup system to regularly back up critical data. Ensure that backups are stored offline or in a secure cloud, as ransomware often targets networked backup systems. Number 2, preventing phishing and social engineering attacks. Phishing and other social engineering attacks exploit human vulnerability. To mitigate these risks, a combination of education, technology, and vigilance is necessary. Advanced mitigation techniques, email filtering, and threat intelligence. Implement email security solutions such as Spam Assassin, Proofpoint, or Mimecast to block phishing emails before they reach users' inboxes. Multi-factor authentication, MFA. Enforce the use of MFA for all sensitive accounts, especially email, banking, and business applications. This adds a layer of security beyond just passwords. Security awareness training. Regularly train employees to identify phishing attempts, such as looking for suspicious links, verifying sender addresses, and avoiding clicking on unverified attachments. URL filtering and sandboxing. Use URL filtering tools to block access to known malicious websites and sandboxing technologies to isolate and analyze potentially dangerous links or email attachments before opening them. Number 3, hardening systems and networks. Hardening systems and networks involves reducing the number of vulnerabilities that attackers can exploit by configuring devices and software securely. Advanced mitigation techniques. Disable unnecessary services. Reduce the attack surface by disabling unused services, ports, or protocols. For example, disable Telnet or FTP in favor of more secure protocols like SSH or SFTP. Patch management. Implement a rigorous patch management process to ensure that all software, operating systems, and devices are updated regularly with security patches. Security configuration and auditing. Use tools like Security Configuration Wizard, SCW, for Windows, or Linus for Linux, to audit system configurations and ensure they follow best security practices. Zero Trust Architecture. Implement a Zero Trust security model where every access request is verified, regardless of whether the request is coming from inside or outside the network. Advanced troubleshooting involves diagnosing and solving complex OS, software, hardware, and network issues using in-depth tools and techniques. Resolving OS boot problems, driver issues, and software crashes requires a combination of recovery tools, diagnostic utilities, and manual fixes. Advanced security threat mitigation involves using proactive defense strategies like network segmentation, endpoint protection, email filtering, and the principle of least privilege to protect against malware, ransomware, and phishing attacks. Hardening systems through disabling unnecessary services, patch management, and the use of security frameworks like Zero Trust ensures that systems remain secure in the face of evolving threats. Chapter 11, CompTIA A+ Exam Strategy. The CompTIA A+ certification exams, Core 1, 220 to 1101, and Core 2, 220 to 1102, are designed to assess your knowledge and hands-on skills in a variety of IT support areas. To ensure success, it's essential to develop a solid exam strategy that combines understanding the exam format, tackling performance-based questions, and managing your time effectively. This chapter will guide you through the key strategies for approaching the CompTIA A+ exams with confidence. Core 1 and Core 2 exam format breakdown. The CompTIA A+ exams are divided into two separate sections, Core 1, 220 to 1101, and Core 2, 220 to 1102. Each exam is designed to test different sets of knowledge, skills, and abilities, focusing on hardware and software support, respectively. Understanding the structure of these exams is crucial for your preparation. Core 1, which is 220 to 1101. This exam focuses primarily on hardware and networking essentials, along with mobile devices and cloud technologies. It consists of the following: multiple choice questions, MCQs. These questions are designed to assess your knowledge and ability to recall facts and apply concepts. Performance-based questions, PBQs. These are hands-on simulations that test your practical skills. You may be asked to perform tasks such as configuring hardware or troubleshooting a system. Core 2, 220 to 1102. The Core 2 exam deals primarily with software, operating systems, and security. It includes multiple choice questions, MCQs, similar to Core 1. These questions will test your understanding of operating systems, security measures, and troubleshooting techniques. Performance-based questions, PBQs. For Core 2, the PBQs will require you to demonstrate your ability to manage and troubleshoot software-related issues in real-world scenarios. How to approach performance-based questions. Performance-based questions, PBQs, are one of the most critical and challenging parts of the CompTIA A+ exams. These questions test your practical, hands-on skills in real-world scenarios and are designed to simulate real IT tasks. Here's how to approach them. Number 1, understand the task before acting. Read the instructions carefully. PBQs will often contain detailed scenarios where you're asked to configure, troubleshoot, or perform other tasks. Take your time to understand what's being asked before starting. Identify what tools and commands are required. Look for clues in the task description that tell you which tools or commands you might need to use. Make sure you're familiar with key system tools like Task Manager, Control Panel, Command Prompt, and Terminal, in case of Linux or Mac OS-based systems. Number 2, stay organized and methodical. Follow the correct steps. In performance-based tasks, staying methodical and organized is important. Take a step-by-step approach to solving the problem. Break down the task and ensure each part is completed before moving to the next. Use process of elimination. If you're unsure of what to do next, look at what doesn't work or which options are clearly incorrect. Eliminate those first. Number 3, pay attention to time. Don't rush. It's easy to feel rushed, but accuracy is more important than speed. Remember that PBQs may be time-consuming, but take your time to avoid costly mistakes. Use your time wisely. If you're stuck on a particular PBQ, move on to the next one and come back later if necessary. Number 4, practice hands-on. Practice in a test environment. If possible, use virtual labs or simulators to practice performing common IT tasks, such as configuring network settings, setting up user accounts, or diagnosing hardware issues. Websites like CompTIA CertMaster Labs and Practice Labs can help simulate the exam environment. Time management tips. Proper time management is essential when preparing for the CompTIA A+ exams, as both the Core 1 and Core 2 exams are timed and can be intense. Here are some time management tips to help you stay on track. Number 1, set a study schedule. Develop a study plan. Create a structured study schedule leading up to your exam date. Break down your study sessions into manageable chunks, focusing on specific domains each day. Prioritize weak areas. Spend more time on the topics where you feel less confident. If you find certain areas, such as security or networking, more difficult, allocate extra study time to these. Number 2, understand exam timing. Know the exam duration. Both Core 1 and Core 2 exams are approximately 90 minutes long and consist of 90 questions, including MCQs and PBQs. This gives you about 1 minute per question. It's important to practice answering questions quickly and efficiently without sacrificing accuracy. Practiced time exams. Use practice exams to simulate the real exam environment. Time yourself during these mock tests to get a sense of how long you can spend on each question. This will help you pace yourself during the actual exam. Number 3, manage exam breaks. Take advantage of breaks. CompTIA offers breaks during the exam, typically after you finish each section. Use these breaks to clear your mind and regain focus before moving on to the next section. Don't overuse breaks. While it's important to take breaks, don't spend too much time away from the exam. Use the breaks to stretch or relax, but aim to keep them brief so you don't lose momentum. Number 4, answering multiple choice questions, MCQs, efficiently. Skip and return. If you come across a question you're unsure about, don't waste too much time on it. Mark it and move on to the next question. You can always return to it later if you have time. Use the process of elimination. In MCQs, eliminate obviously incorrect answers first. This increases your chances of selecting the correct option by narrowing down your choices. Stay calm. If you get stuck on a question, take a deep breath. Stay calm and focused. Panic can lead to mistakes. Trust in your preparation and knowledge. Number 5, handle performance-based questions, PBQs, efficiently. Allocate time for PBQs. PBQs typically require more time to complete as they involve practical, hands-on tasks. Allocate a significant portion of your exam time to these questions. If you're unsure about a PBQ, move on and return to it later. Don't overcomplicate PBQs. Stick to the most straightforward solutions that are likely to resolve the issue. Avoid overthinking or trying to apply complex techniques unless the situation explicitly requires it. Exam format knowledge. Understand the structure and format of both the Core 1 and Core 2 exams, including the breakdown of multiple choice questions, MCQs, and performance-based questions, PBQs. Approach performance-based questions methodically. Take a careful and organized approach of PBQs, focusing on understanding the task, following the correct steps, and managing your time efficiently. Time management. Develop a study plan, practice under time conditions, and learn how to pace yourself during the exam to maximize your chances of success. Focus on practice. Hands-on practice and familiarity with IT tools and procedures are crucial for excelling in PBQs. Use practice labs and simulators to gain real-world experience. Exam strategy. Prioritize areas of weakness. Skip questions that you are unsure about and stay calm to ensure that you perform to the best of your ability during the actual exam. Chapter 12. Practice questions and answers. One of the most effective ways to prepare for the CompTIA A+ certification exams is through practice questions. These questions not only help you familiarize yourself with the exam format, but also test your understanding of key concepts and reinforce your learning. In this chapter, we will provide over 100 practice questions divided into Core 1 and Core 2 topics, along with detailed explanations to help you identify and improve your weak areas. We will also discuss strategies for analyzing your performance and strengthening your knowledge where needed. Practice questions with detailed explanations. In this section, you'll find a range of multiple-choice questions, MCQs, and performance-based questions, PBQs, that cover both Core 1 and Core 2 topics. These questions reflect the kinds of challenges you will face during the exam and are designed to test your knowledge of IT hardware, software, networking, security, and troubleshooting. Core 1 Practice Questions. Number 1. Which of the following components is responsible for controlling data flow between the CPU and memory? A. Hard drive, B. RAM, C. Motherboard, or D. Chipset? The answer is D. Chipset. The chipset on the motherboard controls the data flow between the CPU and the memory. It acts as the intermediary between the CPU, RAM, and other system components, facilitating communication and ensuring efficient data transfer. Number 2, what is the primary purpose of an SSD solid-state drive over an HDD hard disk drive? A. Higher storage capacity. B. Faster read-write speeds. C. Lower energy consumption. Or D. Improved cooling efficiency. The answer is B. Faster read and write speeds. SSDs are faster than traditional HDDs because they use flash memory rather than mechanical components. This results in quicker read and write operations, leading to faster boot times, file transfers, and overall system performance. Number 3, when setting up a wireless network, which of the following encryption protocols provides the strongest security? A. WEP, B. WPA, C. WPA2, or D. WPA3? The answer is D. WPA3. WPA3 Wi-Fi Protected Access 3 is the latest and most secure encryption protocol for wireless networks, offering stronger security compared to its predecessors, WEP, WPA, and WPA2, especially in public and unsecured networks. Core 2 Practice Questions. What is the first step in troubleshooting a computer that fails to boot into Windows? A. Reinstall Windows. B. Check for hardware failures. C. Boot into safe mode. Or D. Check the power supply and connections. The answer is D. Check the power supply and connections. Before jumping into more complex solutions, the first step should be ensuring that the system is properly powered on and all connections are secure. This includes checking power cables, monitors, and ensuring there are no physical issues preventing the system from starting. Number 2, in a Windows environment, which command line tool is used to repair the Windows boot configuration data? Is it A. SFC, Scan Now, B. Check Disk, C. Boot REC, or D. Disk Part? The answer is C. Boot REC. The Boot REC, BOOTREC tool is used to repair boot configuration issues in Windows. Running commands like bootrec, fix MBR, and bootrec, rebuild BCD can help resolve problems related to the boot process. Number 3, which of the following security measures is best for protecting a company's email system from phishing attacks? A, install antivirus software. B, use an email filtering service. C, implement a firewall. Or D, use two-factor authentication, 2FA. The answer is B, use an email filtering service. Email filtering services can help detect and block phishing emails before they reach users' inboxes. These services often use algorithms and threat intelligence to filter out suspicious emails, preventing phishing attacks from occurring. Performance-based questions now, PBQs. In addition to the multiple-choice questions, you'll also face hands-on performance-based questions during the exam. These PBQs assess your ability to perform common IT tasks, such as configuring networks or troubleshooting system issues. Here are 2 examples of PBQs. PBQ 1. Scenario. You've been asked to troubleshoot a computer that is experiencing slow boot times. Upon inspection, the system is running Windows 10 and has 4 GB of RAM. The user has multiple programs set to launch at startup. Task. Identify the best method to improve the boot time without causing data loss. Answer. Open Task Manager and go to the Startup tab. Disable unnecessary startup programs to reduce the number of items loaded during boot. Recommend adding more RAM if the system is constantly utilizing all available memory. PBQ 2. Scenario. A user reports that they're unable to connect to the company's secure Wi-Fi network on their laptop running Windows 10. The user can see the network but is unable to connect. Task. Configure the laptop to successfully connect to the Wi-Fi network. Answer. Open Network and Internet settings and click on Wi-Fi. Select the company's secure Wi-Fi network and click Connect. Enter the network password if required. If the connection fails, troubleshoot by ensuring the correct Wi-Fi adapter is enabled and check for any issues with the wireless drivers. If necessary, update the network adapter driver or reset the Wi-Fi adapter. How to analyze and improve your weak areas. After completing the practice questions, it's important to analyze your performance and focus on improving weak areas. Here's how you can do that effectively. 1. Review the explanations. After answering each question, carefully review the explanation. Even if you answered the question correctly, understanding the reasoning behind the correct answer helps reinforce the material. If you answered incorrectly, the explanation will guide you on what went wrong and clarify the correct concept. Number 2, identify patterns in mistakes. Look for patterns in the mistakes you're making. Are there specific topics or types of questions you consistently struggle with? For example, are you having trouble with hardware questions, network troubleshooting, or security measures? Identify these areas by allowing you to focus your studies on the topics that need the most improvement. Number 3, use practice tests to gauge progress. Retake practice tests regularly to gauge your progress. As you study, you'll likely improve in areas where you once struggled. Notice whether your scores improve over time, especially in the areas where you previously had difficulty. Number 4, focus on hands-on practice. Some topics, especially hardware configuration and troubleshooting, require practical experience. If you find that you struggle with performance-based questions, PBQs, make sure to spend additional time practicing hands-on tasks. set up virtual machines, practice networking setups, or work through real-world troubleshooting scenarios to improve your skills. Number 5, review exam objectives. The CompTIA A+ exams are based on specific exam objectives that outline the topics covered in detail. Reviewing the exam objectives can help you ensure that you're covering all the necessary material. If you find that certain areas are underrepresented in your practice questions, devote extra time to those topics. Practice questions. The best way to prepare for the CompTIA A+ exams is by answering practice questions that mirror the format and complexity of the actual test. Use these questions to reinforce key concepts and test your knowledge. Performance-based questions, PBQs. PBQs test your practical skills. Practice hands-on tasks and ensure you're comfortable working through real-world IT issues. Analyze weak areas. After completing practice questions, analyze your performance and focus on areas where you're struggling. Use practice exams to track your progress and fine-tune your study plan. Hands-on experience. For topics like hardware and networking, practical experience is key. Set up labs and virtual environments to practice troubleshooting and configuration tasks. Regular review. Consistently review concepts and retake practice questions to ensure retention and understanding. Chapter 13. Real-world applications of A+ skills. Congratulations! By reaching this point in your study guide, you've gained a solid understanding of the CompTIA A+ certification material and are ready to put your knowledge into action. In this chapter, we will explore how you can take your knowledge and skills acquired during your study for the A+ exam and apply them to real-world IT scenarios. We will discuss how your CompTIA A+ skills translate into an on-the-job abilities and explore some best practices that will make you an effective IT support professional. Translating certification knowledge into job skills. CompTIA A+ is often the first step in an IT professional's career journey. The skills you acquire through the certification process provide a foundation for handling a wide range of IT support tasks, from troubleshooting hardware issues to configuring software and managing network connections. Here's how A+ knowledge translates directly into practical job skills. Number 1, hardware troubleshooting and repair. In practice, in a technical support or IT technical role, you will frequently be asked to troubleshoot and repair a variety of hardware issues. This may include replacing faulty RAM, diagnosing CPU malfunctions, or installing hard drives and SSDs. A+ knowledge in action. Your understanding of computer hardware, storage devices, and peripherals will allow you to identify common issues, replace or repair parts, and ensure systems are functioning at peak performance. Number 2, software installation and configuration. In practice, as an IT support professional, you'll regularly need to install and configure and update software systems. This includes setting up operating systems, installing necessary drivers, and ensuring that software applications run smoothly. A+ knowledge in action. With your expertise in Windows, Mac OS, and Linux installation processes, you'll be able to install operating systems, configure system settings, and resolve issues like slow boot times or application crashes. Your understanding of system recovery tools will also help when performing repairs or backups. Number 3, networking fundamentals and troubleshooting. In practice, IT professionals often handle basic networking tasks such as setting up network connections, configuring routers and switches, and troubleshooting network issues. This could involve resolving connectivity issues, setting up new network devices, or configuring IP addresses. A-plus knowledge in action. With your foundation in networking basics, you'll be able to diagnose issues with wired or wireless networks, configure IP addresses, and address problems with routers, switches, and other network devices. Your understanding of TCP/IP, DNS, and DHCP will be invaluable in this role. Number 4, mobile device support. In practice, in many organizations, IT technicians are called upon to support mobile devices, including laptops, smartphones, and tablets. This may involve tasks such as setting up devices, troubleshooting connectivity issues, or ensuring that mobile security protocols are in place. A-plus knowledge in action. You apply your knowledge of mobile devices, iOS, Android, and Windows, to set up and troubleshoot common issues, such as network connectivity, battery life problems, and app installation errors. Number 5, security awareness and implementation. In practice, security is a critical aspect of any IT role, especially for professionals handling sensitive data and company networks. As an A-plus certified technician, you'll be responsible for ensuring that systems and networks are secure from malware, phishing, and other security threats. A-plus knowledge in action. Using your understanding of basic security concepts such as firewalls, encryption, and antivirus software, you'll implement essential security practices on systems, helping prevent data breaches and protect company networks. IT support best practices. As an IT support professional, you'll be expected not only to apply technical knowledge, but also follow best practices that ensure effective and efficient support. Here are some IT support best practices that will enhance your ability to perform well in your role. Number 1, adopting a systematic troubleshooting methodology. Step-by-step approach. Always follow a methodical process when troubleshooting. Start by gathering information about the issue, identify potential causes, and implement solutions systematically. The CompTIA A-plus troubleshooting model emphasizes a logical approach that involves identifying the problem, establish a theory of probable cause, test the theory to determine cause, establish a plan of action, and implement the solution, verify functionality, document findings. This structured approach will help you efficiently resolve issues and avoid overlooking key factors. Number 2, communication skills and customer support. Be clear and courteous. IT support professionals often interact with non-technical users, so effective communication is essential. Make sure you explain solutions in simple terms, avoiding technical jargon. Listen carefully to user issues and ask follow-up questions to clarify the problem. Offer helpful documentation. After resolving an issue, provide users with documentation or instructions to help them avoid similar problems in the future. Whether it's guiding them through a basic setup or offering security tips, always leave the user feeling supported. Number 3, documenting and tracking issues. Maintain records. Proper documentation is a key component of effective IT support. Document every issue you encounter, the troubleshooting steps you've taken, and the resolution. This can help you track recurring problems, keep a record of solutions for future reference, and provide transparency for team collaboration. Use ticketing systems. Many organizations use ticketing systems like ServiceNow or Zendesk to manage and prioritize support requests. Get comfortable using these systems to track your tasks and ensure issues are resolved in a timely manner. Number 4, staying up to date with new technologies. Continuous learning. The IT field is constantly evolving, with new hardware and software and security threats emerging regularly. Stay current by reading industry blogs, attending training sessions, and participating in online communities. This will allow you to stay ahead of the curve and bring fresh knowledge to your IT support role. Take additional certifications. While CompTIA A+ provides a strong foundation, consider advancing your knowledge by pursuing additional certifications, such as CompTIA, Network Plus, CompTIA Security Plus, or even vendor-specific certifications like Cisco's CCNA to specialize further. Number 5, proactive maintenance and system optimization. Preventive maintenance. Instead of just reacting to problems, practice proactive IT support. This involves regular system maintenance, software updates, patch management, and hardware inspections to prevent issues from arising. Regularly cleaning up system files, optimizing storage, and running diagnostic tools can prevent many common IT problems. Monitoring systems. Set up monitoring tools to track system performance, identify potential issues before they become problems, and ensure that systems are operating efficiently. Number 6, following security protocols. Implementing best security practices. As part of your job, you'll be responsible for ensuring the security of systems, networks, and devices. Adhere to established security policies, such as enforcing strong passwords, enabling two-factor authentication, encrypting sensitive data, and running regular virus scans. Responding to incidents. Be prepared to handle security breaches or malware infections. Know the steps to take in the event of a security incident, including containment, investigation, and remediation. Document each step and work with your security team to mitigate the impact of the breach. Translating knowledge into skills. The skills you acquire through the CompTIA A+ certification translate directly into real-world job skills that are highly sought after in the IT industry. Whether you're troubleshooting hardware, configuring software, or securing networks, the A+ skills will be a strong foundation for your career. Best practices. Effective IT support requires more than just technical knowledge. Adopt best practices like systematic troubleshooting, strong communication, diligent documentation, continuous learning, proactive maintenance, and robust security measures to excel in your role. Professional development. As you gain experience, continue to enhance your skills by pursuing additional certifications and staying updated on industry trends. The IT field is constantly evolving, and keeping your skills fresh is essential for long-term success. Conclusion. Final words of encouragement. Congratulations. You've come a long way in your CompTIA A+ certification journey. Completing this guide is just the beginning of your career in IT. The knowledge and skills you've acquired while studying for the Core 1, 220 to 1101, and Core 2, 220 to 1102 exams will serve as a solid foundation for a fulfilling career in the ever-evolving world of technology. It's completely natural to feel a mix of excitement and nerves as you prepare to take the exam. But remember that confidence is built through preparation. Stay focused on your goal. Continue practicing with hands-on labs and review the material that challenges you the most. Trust the effort you've put in so far and know that success is within your reach. Just like in the world of IT, there will always be new challenges to tackle. But with your CompTIA A+ certification, you'll have the tools to overcome them. Whether you're troubleshooting hardware, configuring networks, or supporting users, the skills you've developed here will set you up for success in both the exam and the job market. Next steps in your IT career. Your CompTIA A+ certification is a key that unlocks a wide variety of exciting career opportunities in IT. As you move forward, here are some important next steps to guide you on your journey. 1. Take the exam and get certified. First things first, schedule and take your exams for both Core 1, 220 to 1101, and Core 2, 220 to 1102. With proper preparation and practice, you'll be confident in your ability to pass. Don't forget that passing these exams will earn you CompTIA A+ certification, a widely recognized credential that will boost your resume. Number 2, stay current with IT trends. IT is a dynamic and rapidly changing field, so it's essential to keep your skills up to date. Engage in continuous learning by taking advanced certifications like CompTIA Network Plus, CompTIA Security Plus, or other specialized certifications based on your interests. Follow industry blogs, forums, and tech news to stay informed about the latest advancements in technology. Number 3, gain hands-on experience. To complement your certification, practical experience is key. Try to set up your own home lab, volunteer for IT support roles, or seek internships where you can apply your knowledge in real-world environments. Hands-on experience will also help you become more confident with troubleshooting and problem-solving, which are essential skills in IT. Number 4, explore IT specializations. After achieving your A+ certification, you might want to consider specializing in specific areas like networking, cybersecurity, cloud computing, or system administration. Specialized skills are in high demand and can help elevate your career even further. For example, pursuing CompTIA Network Plus or CompTIA Security Plus could be natural next steps depending on your career interests. Number 5, build a professional network. Join professional organizations such as CompTIA's IT professional community or local IT meetups to connect with other professionals in the field. Networking can lead to valuable job opportunities, mentorship, and resources to continue growing in your career. Number 6, look for entry-level IT jobs. Your CompTIA A+ certification opens a door to entry-level IT positions like IT support specialist, help desk technician, or systems administrator. Keep an eye on job postings that match your skills and interests, and don't hesitate to start applying as you build up more experience. You'll find that entry-level jobs provide opportunities to continue learning while getting paid to work on real IT problems. The CompTIA A+ certification is a stepping stone into an exciting, rewarding, and highly versatile career. Whether you're troubleshooting issues, installing hardware, or supporting users. Your skill set will be highly valued in a vast number of industries. Take pride in the effort you've put in to study for this exam, and remember that this certification is just the beginning of an incredible journey in the world of IT. Stay curious, keep learning, and don't be afraid to face new challenges. Your career in IT has just begun, and the possibilities are endless. We wish you the best of luck on your exams and in all of your future endeavors. You've got this. This has